Today we are analyzing functions and their graphs. So, analyzing functions and graphs. So let's look at the most basic one that we can work with, linear functions or the line. So if f of x, let's say, equals 2x plus 3, if I did a quick graph with this, I know it intersects at 3, goes up 2 over 1, up 2 over 1, kind of draw a line like that. If you look at this very poor graph, let me maybe use something stronger. Here we go. Notice here on this graph that it is a positive slope. It is always increasing. So here we can say it is increasing, starting with negative infinity, ending with positive infinity. So from negative to positive infinity, it is increasing. Next, the domain. Well, you can have any x number, so our domain here is all real numbers. So x can be all real numbers. Finally, our range. Remember, that is our y function. Range can also be all real numbers because we can have any y value. So our function or our y is all real numbers. After that, let's go on to next graph here. Let's say we are dealing with f of x. Let's do a quadratic. F of x equals x squared plus 1. We have the plus 1, so we know this is a regular parabola, and it just goes up over 1. If you remember how to graph a regular parabola, it's up 1, up 2, and mirrored, and so on. So let's graph that like so. If I have to put here, we know that it has a minimum. So if we analyze this, this has a minimum of 0, 1. That is our minimum and also our vertex. But let's talk about this graph here. Notice here in this graph, some part of it, if I drew a line in the middle, notice that starting from our left side, from negative infinity, heading towards the right, so we always go from left to right. If you were to look at that line, it is going down. So it is decreasing. So we can say it is decreasing from negative infinity to what? 0? So negative infinity to 0. Then what is it doing after the 0? Look at that. It is going up. So it is actually increasing as it goes up. So we first say it's decreasing, and then it is increasing from 0 to positive infinity. Next is our domain. Well, our domain, our x value, can be any real number. So domain here, once again, our x can be all real numbers. And our range is our y or our function. And basically, since it has a minimum, it can be all real numbers. However, f of x must be greater than or equal to the minimum, which is 1. Okay, let's work with an absolute function here. Let's go to this next one. What if our f of x equals the negative absolute of x. As you all know, our negative flips it upside down. We're starting at the origin. So if I were to graph that, it kind of looks like this, goes all the way down, kind of looks like a V, all the way down. Let's analyze this. Notice here at the very start, it is increasing. If we are on starting from the left, it increases, it is going up. So we can say increasing from negative infinity to 0, and then from there it starts to go down. So it is decreasing from negative infinity to 0. Oh no, 0 to, it's decreasing from 0 to positive infinity. Sorry for that. Nextly, our domain. Our x can be anything, so domain once again is all real numbers. Next is our range. This time it has a maximum. Our maximum is 0, 0, right? The origin, 0, 0. So our range is f of x or y has to be all real numbers. However, f of x is also then less than or equal to 0. One last graph. Let's scoot this on over. And let's work with a mixed graph. Let's say our function is f of x equals the absolute value of x plus 1 plus the absolute value of x minus 1. Well, I know here that this is kind of where I know we are working with absolute values. But let's think about this. What if we were to put in the number 1, right? If we put in the number 1, wouldn't that equal what? 2 plus 0? So if we put in the number 1, we're going to start at 2. If we put in the number negative 1, we're going to get 2. What if we put in 0? If we put in 0 into our function, it is still going to be 0. Let me create a quick table for the units that I have used so far. Here we have our x values, inputs, outputs. At negative 1, x at negative 1, y equals then has to be 2. At x is 0, y is 2. At x is 1, y is also 2. And I know since this is absolute values, it's going to mirror each other. So I'm just going to keep going positive. So if I plugged in 2, 2 plus 1 is 3, the absolute value of 3. 2 minus 1 is 1, so 3 plus 1, that is 4. So the next value is up 4. It's going to have, so let's put the next one, 3. 3 plus 1 is 4. 3 minus 1 is 2. 4 plus 2 is 6. So it's going to look like this on one side, and I imagine the other side is going to mirror it just so. Finally, with this in mind, this tells us that the domain has to be all real numbers. And the range, since there is a minimum, the range has to be f of x must definitely have, they could equal 2, but has to be greater than or equal to 2. Finally, one last concept. don't forget our functions concept. If the vertical line test, I'm just going to draw a quick line here, xy coordinate. If somehow our line looks kind of squiggly like this, and we draw a vertical line and it crosses in more than one places, bam, 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 it is not a function. Remember, the vertical line, if you can draw a vertical line up and down, it can only cross in one place. And that is all for today.